So today the topic is Async Ruby. This is a topic that is very, very dear to my heart, and I'm very excited to tell you everything I know about Async Ruby. Couple slides about me. My name is Bruno Sutic, and I consider myself to be Async Ruby early adopter. You can find my contact info on my webpage, brunosutic.com, and that is my GitHub handle. As far as work go, I created my own web app called linkok.com, which is a modern broken link checker. And a lot of the work that I did with Async Ruby, I worked on that project. Right now, my kind of work in progress project is Rails billing. It's about fast Stripe subscription integration with Ruby on Rails, and do feel free to ask me about it, after the speech. As far as my Async Ruby involvement, I consider myself to be working like pretty much 2 years full-time on Async Ruby as part of a linkok project. And what I did was implemented a sophisticated web crawler that is based on async technology. I worked on a couple async-only gems, and async limiter is like the only one that I kind of made public. And I did made one Ruby core commit, which is about making DNS requests asynchronous. All right, let's dive into the topic. What is Async Ruby? Like the definition, I'll have to go through it, is like a fiber-based concurrency for Ruby. If we were just chatting, I would say, look, for 90% of the cases, it means you want to run many, many HTTP requests at once, okay? A couple other lines that are usually associated with async programming paradigm, because like async programming does exist in other languages, right? So async is like a modern and lightweight IO concurrency. It usually contains like a brain of the operation, which is called event loop or reactor. And this is totally unofficial, but this technology kind of gained a mainstream popularity 2010 and later. And it was the popularity was driven by the Node.js and the rise of modern JavaScript. Okay, so everything that I'm going to show you today, and like pretty much the whole ecosystem, has been driven, maintained, and developed by the Ruby core team member, which is called Samuel Williams, right? He's not like a big star, but he's the guy that really like implemented everything that I'm going to talk today. If you see him, buy him a beer. Okay, so where does, in the Ruby landscape of the features, where does Async Ruby fit in, right? It's a concurrency model, so there are a couple other concurrency models that Ruby has. First off is multiple processes. If you want to run multiple things at the same time, you spin multiple Ruby processes, there you go. Next up, the new technology is the reactors. And it's been driven by the operating system threads, okay? So you have one Ruby process, it runs on multiple CPUs, there you go. Next up, we have threads. It's an old technology. Also, the primitive for it is operating system threads. And as we all know, the limitation of Ruby threads is the global interpreter lock, okay? So you can have only one thread running at the same time. This same limitation, the global interpreter lock, also applies to Async Ruby, okay? And the differentiation is the core primitive of Async Ruby is fibers. I want to do hands up. So who has kind of have any experience with like running multiple processes? Okay, a lot of people. Okay, how about reactors? No one. How about threads? So you have written threaded code. Okay, about half. Oh, hey, so did anyone play with fibers on Async Ruby? Okay, there are people. Okay. All right, so what Async Ruby is not, okay? So this is just to disambiguate a couple of things. So Active Record has this cool feature, really is a good feature, which is like called load async, and there's a plethora of methods that have async in the name. That feature uses threads in the background, so it's not like fiber-based. It's technically in English language, it does run asynchronously, but when we talk about programming context, this is not Async Ruby. Same with Sutic, it has the perform async method, and we all know that Sutic runs multiple threads. It's a threaded program or a library, so that's not really Async Ruby. That's not the topic of the speech today. This slide shows like the main components of what is considered to be async Ruby. The red parts are features and technologies that are kept, maintained, and implemented in C Ruby, and the white stuff is outside C Ruby, that is just gems. Let's start with async the gem. You just do gem install async, and there you have it. It's not just any gem, right? So Matz invited this gem to a standard library, and I think the invitation is still pending, and I do have to ask Matz what's going on with that. Okay, so the gem was implemented by Samuel Williams, the guy that pretty much worked on all these features that you see on your screen right now. And when we talk about work with async, this is like the user-facing library. This is what you and I are interacting with the most. Next up is the IO event gem. You can do gem install IO event, but you usually do not do that because this gem is really, really low level. It is implemented as a C extension, and it implements technologies that are with names such as KQ, EPOL, and IO Euring. Okay, this is where the main logic, where the fiber scheduler is implemented. It is low level. Next up, we're going into the C Ruby source code, and we have the Fiber Scheduler interface. Fiber Scheduler has been added to Ruby 3.0, and that is one of those features that's like big. You read it in a release notes, it's like, okay, this really is something, and then you want to try it out and you don't know what to do with it, right? And that is fine, because actually this feature also is low level. It was added to C Ruby exclusively to support, the IO event gem and the async gem. Okay, so you can see, like, this whole ecosystem paradigm really does have support from like the Ruby source code, right? This is not just one guy's gem. This really has support from Ruby core. Okay, just to dive into this topic a little bit more. Fiber Scheduler interface contains hooks for blocking IO operations. For example, you make an HTTP request. You are first writing to a socket, and then you're reading from a socket when a response receives. And at that point, the Fiber Scheduler interface gives the opportunity to the IO event gem, the brains, to hook up there, and like while it's waiting on an HTTP request to response to be received, to schedule some other fiber to do some useful work instead of just waiting. The Fiber Scheduler interface is an awesome feature in Ruby programming language, and it makes async Ruby colorless. We are going to touch on that in the example. I think it's going to be clear what's going on. As with all these features, there's like lot more depth to it, and I did write like a blog post, so if you guys want to dive in, you can read more about it. Fibers have been in Ruby before, async Ruby. It's like a old feature, and it is a primitive for async Ruby. The simplest explanation is like lightweight threads. The technology has been optimized in assembly, so not C code, in assembly, which is even more performant. In order to create a fiber, to switch between fiber and destroy a fiber, you do not need to invoke or make system calls. This makes fibers more lightweight and faster than, for example, working with threads. This has, like, the fibers do have a lot more depth to it. I'm not going to go into today, but if you're interested, if you want to understand what fibers are, Google stuff like stackful coroutines, and don't Google Ruby because no one is writing about it in Ruby. Do Google C++. Okay, so because like most of the innovation with fibers and like these low-level technologies happening in C++ world, and Ruby is just adopting it. Aside from like the core libraries and interfaces, we have a number of async-specific gems. The notable mention is Async HTTP, which in my mind is like the most performant Ruby HTTP client that no one knows about. It's great. Also, there's a Falcon, which is an async web server. Let's move on to examples, starting with the basic ones. Before jumping into async Ruby, I want to kind of, set the ground and do like a very simple example. All the examples are going to be like simple today. So we are doing 3 operations, 2 HTTP calls, and do know that these HTTP calls are calling this HTTP bin, and these calls take 2 seconds to run. plus some latency, network latency, okay? We're using URI open, which is built into Ruby, HTTP party, which is a third-party gem, and then lastly, plain old sleep. The operations take 7 seconds, okay? This is synchronous, it goes step by step, so we have to wait a little bit longer. Let's rewrite this example with Async Ruby. I do want to, kind of explain two concepts, which is the top-level async block, the capitalized kernel method. Okay, that async block, opens up, sets up the world for async, and it's there inside this async block that the fiber scheduler is set. Right, so for the duration of the async block, any fibers that are created inside of there will be, scheduled by the ION gem. Okay, so that's where it kicks in. Another concept that we have is the async task. Okay, so multiple tasks run at the same time, and I do want to bring up that tasks are just wrappers around fibers. Okay, so you're probably going to hear me task fiber interchangeably because they're really closely related concepts. As a result of this refactoring with async, now total execution time is just a little bit greater than 2 seconds, which indicates to you that all these 3 operations ran at the same time. Do you remember that async is colorless statement that I made earlier? So what that means is that for the synchronous Ruby example and this one that is async, we are using the same methods. You can compare that to, for example, JavaScript. We have all written a little bit of JavaScript where, in order to use these asynchronous methods, you have to, for example, annotate them with async and then later on with await. That makes JavaScript colored async paradigm. In Ruby, it's all the same. You write the same, you use the same method, same interface, and that is great. You want to have that. This is also a simple example, but what happens when you make a single request and then use the response to create another HTTP request? How would you do that? Would you use a promise like in JavaScript? No, in Ruby, you just write synchronous code. So this example is showing that okay, we're back to square one, just line number 1, use the result if needed to make another HTTP request. Yes, you can make promise, you can write code like promises in JavaScript. For example, you can use task.async and then wait on the result. But practically, there's no need to do it. You just write your code the way you would, just simple Ruby code. Okay. The rule of thumb is you keep related operations in a single task, so they run synchronously. And if you have unrelated operations, then you can split them into tasks. Then they can run at the same time. The execution time of this example is pretty much not relevant, but it's back to 7 seconds because it's synchronous now. Nesting tasks. So you can nest tasks arbitrarily. So you can see, we have a subtask and then we're calling async again, which creates a subtask. Subtasks can be created in 3 ways. So if you have a reference to a task, you just call async, creates a new task. If you do not have a reference to to a task variable, you use async task.current, which is a current task, and then again async. Lastly, we have maybe this is a little bit surprising, but you can call this capitalized async method, inside existing async block, and that will just create an async task. That may be surprising. Out of these 3 approaches, I kind of prefer the first one because it's kind of clear, and I like to keep the capitalized kernel method as just the opening async block, okay? But it's fully supported. If you like it, you can use it. This brings us to the next kind of point, the next thing that I want to emphasize is you are free to extract your logic however you prefer, okay? You do not have to keep your async logic inside this async block, which just grows and grows to thousands of lines. No, you use methods, you use classes and modules to extract and factor your code however you see fit, and use, the tools that you have. The takeaways from the basic example group is okay, we have this top level async block, tasks are just wrappers around fibers, and you write your code synchronously, and put it in a task, it runs great. So it's all just Ruby, you refactor it how you see fit. Before jumping into the next example group, let me describe you the feature that we're going to build. Let's say you have a weather app, okay? And the biggest feature is you want to show the weather as fast as possible to the user. And there's a plethora of weather APIs on the internet. You chose 5 of them because you want your app to be super reliable. So if one of those APIs is like slow, unreliable, flaky, whatever, you got it with the rest providers. So what you do is once the user opens the app, you trigger 5 HTTP responses. You use the fastest, the first response, and then you discard the rest of these responses, the slow ones, okay? Here's how you would do it in Async Ruby. In order to accomplish this, we're introducing this new class, Async Barrier. It comes with Async Gem, so you kind of have it by default, and it is heavily used. So it's like a basic class. The best way to explain what Async Barrier is, it's a group of async tasks. Okay. Once you have a group of tasks, like for whatever reason, you can perform actions on it. If you call method async, it will create new task and add it immediately to the group. If you call like stop on a group, it will stop all the tasks in a group, and wait behaves similarly to a promise.all in JavaScript. It will wait, it will iterate over tasks in your group and wait on each one. So you use that group to create 5 HTTP requests. You use group.async. So I want to emphasize that calling async is like a pattern. It almost always creates an async task, and then it does some other action associated with the task. In this case, it immediately adds a task to a group. We're now making API requests, and we have this random in the URL, and we're just simulating slow responses. The first task, the first HTTP request that finish will stop this whole group. It will discard the other results because we don't care, they're slow. Do know that we are spinning another task. So this task will not be a part of a group because it's not group.async, it's just task.async. And then we're using that outside task to stop the group. This is like a small gotcha because we do not want to use any of the tasks inside of a group because it might kill itself and then it will not kill the other tasks, okay? Small gotcha. You can see the output, it's kind of predictable, right? We are starting 5 tasks, and then like the first task that finishes is the task number 1, it kills the other ones. Another feature, you have an API provider, and it has a limitation. You can only make 2 HTTP connections, HTTP requests at the same time. Here's how you would do it with Async Ruby. We are introducing another concept, another class that's pretty basic that comes with the Async Gem itself, which is called Async Semaphore. We are instantiating that class with a limit of 2, right? That's our limit for the API provider. Then we're using like semaphore.async. This is the same pattern that I mentioned earlier. So it does create another async task and it does something else implicitly. In this case, it limits the execution of a task to 2 at the same time. And then we're performing our work, and this is the output that you can see on the screen. If you look at the starts and ends, you can see that any given point in time, the maximum of 2 tasks are executing at the same time. Okay, so one task has to end in order for the other one to start. The takeaways from these 2 last examples are asynchronous tasks are really easily controllable. You can group them, like wait on them, spin new tasks really easily. So yeah, they're really manageable, This is my favorite example group, which is scaling. In order to show it, I want to introduce a couple other operations. So this is like starting from the basic example task where we have HTTP request and sleep, the 4th operation, 4th task. And I'm adding like a Redis operation, which is like just like a random operation with a timeout of 2. So this operation will take 2 seconds. I'm introducing a SQL gem, which is running a Postgres Postgres query, which also takes 2 seconds, is pretty much sleep. And then lastly, at the bottom, the last operation is spawning a system process, which is a simple sleep of 2 seconds. You can see at the bottom, the total execution time is 3 seconds, right? So these tasks run at the same time, and there is some latency introduced by the first task, which is HTTP request. Okay, let's run all these tasks 10 times. So we do 10 times, that is the only change here. And we are now up to 50 tasks. You can see the total execution times, slightly below 4 seconds. So yeah, I mean, there's some like overhead, but these tasks run at the same time. Let's crank things up 100 times, repeat everything. We're up to 500 tasks. If you see total execution time, it's slightly before 5 seconds. So yeah, there is some overhead that is accumulating. But yeah, this is running at the same time. In order to get this example to work, I did have to so I was running all this on my laptop. I did have to tweak my local Postgres configuration to increase the max connections in order to get this to work. But other than that, it just worked. And the last and my favorite example is we are cranking things up 1,000 times, okay? This is now running 5,000 operations at the same time with Async Ruby. In order to do that, I had to switch, instead of URI.open, I'm using now Async HTTP, which is like the gem I mentioned, which is great, the big guns. And Async HTTP is using HTTP 2. So the benefit of it is only creating one TCP connection, performs one HTTP handshake. So it radically reduces the overhead of making 1,000 HTTP requests. Total execution time, again, with some overhead, it's slightly below 8 seconds. So yeah, these 5,000 operations do run at the same time. The takeaways from this example group, look, I mean, I think this is easy to scale. It's really easy to crank up the numbers to something mind-boggling. And the only thing really that you have to take care of is like, well, don't crash your database, or don't crash the target HTTP target API server that you're connecting to. You have to be careful. Okay, so I bet that someone in this audience, there is a skeptic among you saying, well, Bruno, async is fine, but I could do everything that you just showed with plain old Ruby threads. Okay, fair enough. And I want to address, because of that, async is compared to threads very often. So I want to do comparison async Ruby with threads. And there are some pros and cons to both. Let's revise the ideal architecture with Ruby threads. And by doing this, keep in mind the popular libraries like Sutic and Puma and how they work. We all know that. So Sutic and Puma, at the start of the process, they start 5 or 10 or 20, 20 threads. These threads live forever, or practically until the process ends. And during the life of the process, these threads are kept as isolated as possible. So yes, you can group threads and manage them, but you do not want to do that. For successful, really successful projects, they are kept as isolated as much as possible, because otherwise you get bugs. And then these threads pull work from either a shared queue, or in the case of Puma, they're reading requests from a socket, do work and output responses. A quick comparison with fibers. So, with threads 20, 30, 50, that's pushing the limits. With fibers, you can go thousands plus. Threads are monolithic, you start them, you do not touch them, you do not intervene them. Fibers and async Ruby tasks are much more controllable, manageable. You can make them do work for you. And lastly, with fibers, there's no special architecture that you have to employ, right? You just write your code synchronously and it will work inside async. Let's do more comparison of async versus threads, okay? So threads, the basic construct is operating system threads. With async, it's fibers. It's all implemented in Ruby source code, so there are no system calls that need to be performed for a fiber to be created or switched. Because of that, async fibers or just fibers in general do have like a relatively small overhead, and threads do have some bigger overhead. The concurrency with threads, look, if you are running 100 threads per process, you're really stretching those boundaries, and you are really pushing it. With async, like tens of thousands is no problem, and the highest number that I've heard of is the creator of async ecosystem, Samuel Williams, has run server with 2 million concurrent fibers with async Ruby. This is a deep topic, but scheduling with threads, it's called preemptive. Like, I'm going to simplify it. This is not scientific, but with preemptive scheduling, you kind of get random switches from thread to thread. Like, a thread can be switched at any given point of time. With async, the scheduling scheme is called cooperative, which means the IO event gem will switch from fiber to fiber only when the first fiber or first task kind of declare, okay, I'm not waiting, it's okay to switch, and then the scheduler switches fibers. Control, how hard is to control threads? It's possible. Threads do have constructs like thread groups, they have condition variables, they have mutexes, they have various synchronization primitives, but look, it's hard. If you can avoid it, you will avoid it, right? Think of like how Sidekick and Puma work. They keep things isolated and they're successful libraries. With async, as we saw in the examples, you do get that fine-grained, manageability of fibers. Common errors with threads, if you try to, employ mutexes, thread groups, you will shoot yourself in the foot. It's very, very common to have bugs with threaded code. With async, the main concern really is you're going to crash your database, or you're going to crash a server, or you're going to get rate limited. So for these reasons above, right, is it really advisable to write threads as your application code? Well, be really, really careful. Really, really careful. Make sure that you really know what you're doing, and do dedicate weeks to debug your threaded code, to run it, to make sure it doesn't have bugs. With async, it's common. It's common to have async code like just written as a part of your application. There is like a couple of advantages to threads. They have been with us since like practically forever, so there is a big body of knowledge around Ruby threads, okay? You have books, there's like a lot of question and answers on Stack Overflow, so if you get stuck in the thread with a thread question with like an advanced scenario, you probably will find an answer. Async, the current iteration, has been with us since Ruby 3.0. So look, there are good guides, decent guides. The community is great, really responsive, willing to help. But if you have like that, like advanced scenario, you will probably end up reading source code. Threads are better for CPU work, okay? So if you have CPU work, a thread scheduler will make sure that each thread kind of gets a portion of CPU time. With async, if a single fiber has a long-running CPU task, it will run until it completes. During that time, other fibers will not get scheduled, so they will not get any CPU time. In a way, that's called like a CPU starvation, or in this context, the fiber starvation. So if you have CPU work, threads do have a slight advantage. So for that reason, if you have like a classic Rails app that has like a lot of view rendering, like a lot of CPU work with view generation, like a 50, 100 millisecond is spent on view generation, I would give like a slight advantage to threaded web server. Like a classic example is Puma for classic Rails app. With async, we do have a Falcon, which is an async web server. It's great, but do make sure that you have a fitting use case before using it, right? So either you have like an API-only application that does heavy I/O, does heavy networking, heavy HTTP requests, or similar. So I do want to promote Async Ruby. There are really like ideal use cases for it. So I have done like, a crawler. I testify it's great. If you have like a chat app, if you have any kind of a streaming example, great fit. WebSockets also work great. Some of the other things that I've done, and I want to get this out because really, this is not a question, should I use threads or should I use async Ruby or fibers? You can use both. And these are the examples that I've done. And both involve running many HTTP requests. So inside of a Sutic job, I have run many, to kind of make things faster. I have run async with doing many HTTP requests. And same with Puma. I had a situation where I have to do like 4 or 5 requests that go at the same time. And I've done it in a Rails controller, of course, factored properly, but it's all been working inside Puma, and it is great. So a couple common questions like does it work with Rails? Yes. I mean, Jean Bussier, I think, is the guy that is pushing this work forward. It does work with Rails. There is a guy on that had like this speech about running, async the Falcon server with Rails. It works normally, so you can check out this YouTube. Is it production ready? Does it crash? I run an application in production. It does run just fine. There's nothing that makes me, say, oh, this crashes often or anything. It is stable. Lastly, if I kind of got you interested and you want to try it out, where do you get started? I think the best place to start is the official repository. As I mentioned, the docs are really good. There are official guides. But look, this is like a new paradigm and you may get stuck. Do ask questions. The community is responsive. It's helpful. But again, if you kind of push it, if you have like an advanced use case, be prepared to kind of dive into the source code and read it. Thank you all. I mean, as I mentioned, I am really excited to talk about this project. So I'm thinking we do like a small async workshop at 4 p.m. That is in about 50 minutes. Restaurant, second floor. If you guys have questions, feel free to ask. I'm really interested in kind of helping you get started, and we can even do like more advanced examples, demos. There's like some mind-blowing examples with async. If you want to reach out, feel free to contact me via email. You can find it on my webpage brunosutic.com. Thank you, everyone.